We're now into logarithms. This is handled in the grade 12 normal maths class, but only to a small extent compared to what happens in advanced maths. But this is to your advantage. Let's first relate it to exponential functions. So let's have a look at the graph of the exponential function y equals 2 to the x. All we do is plot three convenient points. We know that anything to the 0 is 1. So when you're plotting an exponential graph, it's always good to have the middle value as 1. You should know the shape is approximately like that through 1, asymptotic to the x-axis. So putting those onto the actual graph, there are the points, and let's draw the graph through there. So that is y equals 2 to the x. Now we're going to look at an inverse function of y equals 2 to the x. An inverse function actually reverses the function. You'll see that is the function f. Now we're going to draw the graph of f minus 1, which is the inverse function. The way an inverse function works, if f of a equals b, then f minus 1 of b equals a. So we go from a into the function to get b. Now we put b into the inverse to get a. And it's obtained by swapping the x and y values, always to find an inverse function. So there we are, y equals 2 to the x there. Now we have x equals 2 to the y. So what I'm going to do is I'm going to duplicate that table with y's instead of x's. Now we're going to have the y value of minus 1, and then the x value will be a half. So minus 1 and then a half, because we're plotting from y first. Y is now what are called the independent variable. So there our 3 points are, and we'll draw in the graph, and you'll see it's asymptotic to the y-axis, which is logical, the negative part of the y-axis, because it's swapping x and y, and the exponential function is asymptotic to the negative part of the x-axis. Now note that in fact, if you draw the line y equals x, that this f minus 1 is a reflection of f. You'll see from these arrows, I could fold this about to there, through this line, and it'll be an exact replica of it. All functions and the inverses are symmetrical about the line y equals x. Now, having a look at logarithmic notation. We started with y equals a to the x, and then we have the inverse function x equals a to the y. That gives us a problem, though, because that's easy enough, because f of x is y, so f of x equals a to the x. But now, this one here, f minus 1 of x equals, and we don't know what to put here because we don't have y equals, we have x equals. We need a function for it. So thank you to John Napier, a Scottish mathematician who came to the rescue and introduced this logarithm notation. I don't know where he got the word from, but very interesting. As a power, 2 cubed equals 8. Now the inverse, that's the exponential form. The inverse, we say log of 8 to base 2 equals 3. Or logarithmic form, log of 8 to base 2 equals 3, or log base 2 of 8 equals 3. Let's go into this logarithm a bit more. You'll see we now have a function to write as the inverse function. Two is the base in the exponent, and there's the base in the log, and it's still the base. There's the number, 2 cubed equals 8, well, log of 8. So the number, you'll see where the number goes inside the log. And then there is the exponent, 3, which actually tells you, in fact, that a log this is equal to that 3, which is the exponent. A log is an exponent. And they follow all the exponent rules. So let's practice writing exponential notation given logs. So we have here log of 25 to base 5 equals 2. Well, we know the log is the exponent, so there's the exponent and there's the base. So pretty much that 25, there's only one place for it to go. 5 to the 2, 5 squared must equal 25. And there is the exponential form, and there's the logarithmic form. And of course, we have the base of the log is the base and the power. There are 5 base, 5 base. The log, and that's the log because that's what the log's equal to, is the exponent in the exponential function. So this one we do the same thing. Base to the exponent equals number. Base to the exponent equals the number. Oh, well, what's happening here? We don't have a base. It's taken for granted in maths that if there's no base written there, then it actually is base 10. So without base means that it's base 10. So log of 100 means log of 100 to base 10. So that means we've got base 10 to the exponent equals 100. And there's your exponential form. Here's some practice for you. So if you haven't done these, pause the video and try these out, just writing them in exponential form. The answers. Base to the exponent equals 49. It's always base to the exponent, 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 base 10 to the exponent. Now we can actually solve a log, work out the value of a log by putting it into exponential form. So if we have x equals log of 7 to base 7, we can write that in exponential form, and we're used to solving exponential equations. So that gives me base to the exponent equals 7. And of course, 7 is 7 to the 1, so therefore x equals 1. We equate the exponents, which tells us, therefore, that log of 7 to base 7, which is equal to x, is equal to 1. Let's do another one like that. Log of m to base m. So the exponent is x, the base is m, so we can write m to the x equals m, so x equals 1. And once again, it tells us the log of m to base m is 1. So now we have log of 1 to base 5. So we're going to write that in exponential form. The base to the exponent equals 1. Now we need to work out what x is. Well, 5 to the what is 1? 0. So therefore we have x equal to 0. That means it's a 0 there, which means log of 1 to base 5 is equal to 0. There's another one. Base k to the x equals 1. Now k to the, if I ask k to the what is 1, k to the only one thing is 1, and that is 0. So therefore, log of 1 to base k is also 0. Log of 1 to base e. E is actually a very useful number, constant in maths. We'll be dealing with it later. That is a constant also derived by Napier. So e to the x equals 1, which means x equals 0. So that tells us that log of 1 to base e is also 0. Let's have another case now. X equals log of negative 2 to base 2. So we need to say 2 to the x equals negative 2. Now, to what power do we have to raise 2 in order to obtain negative 2? That's a problem. It's not possible because 2 to the 1 is 2, is not negative 2. We could try 2 to the negative 1, but that gives us a half, not negative 2. So in fact, what it means about log of negative 2 to base 2 is that it is impossible. You cannot have log of a negative number. So to summarize, log of a number to the same base is 1. Log of a to a equals 1, a greater than 0. Notice that I'm just using that fact that we cannot have a negative. Log of 1 to any base greater than 0 is 0. Yes, bases cannot be negative or 0 either. And log of a number less than or equal to 0 does not exist. Now we're going to evaluate the following logs by writing them into exponential form. So there's some steps to take. In each case, we're going to, first of all, equate the log to x. Ultimately, you'll be able to do a lot of it in your head, in fact, once you get used to them. Secondly, we're going to write the log in exponential form. So each of these I'm going to go to exponential form. Finally, I'm going to solve the resulting equation for x. So I'm going to reduce this to base 2, so we'll have 2 to the 2x equals 2 to the 3. So equating the exponents, 2x equals 3, or x is 3 over 2. And x was log of 8 to base 4, therefore log of 8 to base 4 is 3 over 2. 5 to the 3x, 5 cubed, 5 squared. That means x is 2/3. And that's equal to log of 25 to base 125. 27 to the x equals 1/3, so that's 3 cubed, so we have 3 to the 3x equals 3 to the 1. Equate the exponents, 3x equals 1, therefore x is 1/3, which is therefore log of 27 to log of 3 to base 27. 3 to the 2x, 3 to the negative 3 because it's inverted, so negative exponent. So we have 2x equals negative 3, give you x is negative 3 over 2. So log of 127 to base 9 is negative 3 over 2. Note that a log can be equal to a negative value. You can just not have log of a negative value. This one here, once again, we're going to have a negative exponent to invert. So 2 to the negative x equals 2 to the 5. That gives us x equals negative 5, which is therefore negative 5 is log of 32 to base half. A bit of practice for you. Once again, pause and try these yourselves. The steps along the way. Note with this one, you can write that as fractions if you want to. It might be easier that way. In number 8, that case there, take the contents of the bracket alone and work it out, because this squared has nothing to do with writing in logarithmic notation or exponential notation. You can pause and do it, but here are the answers for you to check when you get there.